Hello, meteorologist Brian Wolf here, and I figured we could dive into the nuts and bolts of this potential snowstorm that's going to impact the Ohio River Valley as we move throughout the day on Sunday into Monday. So, again, this is Wednesday afternoon, January 1st. So, if we're going to look, and today we're going to dissect the models, okay? We're going to dissect the differences between the GFS and the Euro models. And there has been some movement since yesterday's update. So if we're going to start, we'll start with the GFS model. And I'm going to forward this to about, Saturday afternoon. As you're looking on your screen, you're going to see it coming from, out west over the plains, and it's going to be moving east again into the Ohio River Valley. We'll go ahead and put this into motion. This is the GFS. We're going to watch the track of where the low pressure is going. You can kind of see this kind of go through. Now, if we rock this back, just to kind of give everybody a heads up, the blues indicate snow. Now, this is just forecasted snow. Keep in mind, we're 4 days out. So there's still a lot that's going to change. We will start to kind of look at some model forecast on amounts, but I don't want you to focus too much on that, right? Right now is when you want to really be looking at model trends. What are they doing? And then that's where you can kind of start to get an idea of how everything's going to shake out. So on here, blue is snow, purple is freezing rain. You've got rain and sleet mixed in there as the kind of the pinkish orange color, and then green's obviously rain. Now, if we kind of rock this forward, the low pressure system is going to be going southern Kentucky for the GFS. Now, I do want you to notice the heaviest precipit's obviously going to hit out front of the low pressure track, but you typically see the heaviest snow bands about 100 miles north of where that low pressure track's going to be. So there's some reasons that we're going to talk about why it's important for where the low is tracking, because if it tracks too far to the north, let's say you're interested in a forecast in Louisville, for instance. If it tracks too far to the north, then you're going to be bringing in that freezing rain chance, the sleet chance, and that can really cut down on your snow ratio. So that's kind of what the GFS looks like. And if we switch over to the Euro model and look, we're gonna play this out and let you see the Euro come in. Now, some noticeable differences, right? Yesterday, the GFS had kind of hinted a little bit more north. The Euro was staying the low pressure across the Kentucky-Tennessee border. If we rock this back and look, the low pressure here, which is indicative by that red L there, is actually coming up and about central Kentucky. So is what that would do is that would put places like Louisville and Cincinnati and Evansville and northern Kentucky starting off with a mix with some sleet and freezing rain, and the snow band, the heaviest snow bands being in south central Indiana up towards, Bedford, Bloomington, up as you head towards Indianapolis. So why, again, does all this matter? Well, when you start dealing with forecasts, because you're probably sitting there watching this video and you're like, well, I want to know how much snow is it going to... Well, you've got to understand the atmospheric dynamics, and that's the difference between a weather enthusiast giving you information and a meteorologist giving you information, is you're going to be able to have that explanation of the dynamics that are kind of going on play. One of the things I want to point out, and again, if that low pressure inches more towards the Ohio River, you're going to get more warm air that's going to infiltrate the atmosphere. And that's noticeable if you look at the 850 millibar temperature, height, and wind map. You can tell there's cold air advection and warm air advection, right? So warm air advection is where you're going to have warm air that's literally advecting or moving into another area. So in order to see that, you look for these wind barbs here. That's what these are called. It indicates wind direction and wind speed. And when you look for these wind barbs, you want to see them crossing over the temperature gradients, which are the colors you see on the map. That will tell you whether it's warm air advection or cold air advection. So if we're looking at the Euro model, and we forward it in here, and you can see the storm drawing close. Here's what I want to point your attention out. So the Euro model being statistically with winter weather more accurate than others. I want you to look at some of these wind barbs. So if I focus on southern Illinois, but this is a classic example across southern Indiana, Kentucky, even Ohio, where you can see these wind barbs. See how they're blowing from south to north, and they are directly perpendicular to these temperature lines. That means there's going to be warm air advecting in. And if we actually go back and look, and we fast forward through into this storm, you can actually see, across like Evansville, for instance, 6 degrees Celsius. So that's obviously above freezing because 0 degrees Celsius would be freezing. So right now, the Euro model is favoring more of an ice storm setup for like central and northern Kentucky, extreme southern Indiana. And my guess, just from looking at this, would be that that snow band has moved a little farther to the north. So I want to go ahead and we'll skip forward here. We'll stick with the Euro model, and I want to look at um, the Euro model. Sometimes the GFS is going to put out information much longer into the future than the Euro model. So the Euro model, I wanted to pull up total snowfall. Now you can see on here it's talking about total snowfall of 10 to 1. So what that means is for different temperatures in which snow can occur, you have these snow ratios. So 10 to 1 means for every 1 inch of liquid precipitation that falls to the earth from the atmosphere, you would see 10 inches of snow. Okay. If it's really cold, you can sometimes see 20 and 30 and 40 to 1, which means 1 inch of liquid precip would equal 20 and 30 inches of snow. We're going to still be warm enough right there in the upper mid to upper 20s that we're going to see roughly right around probably 8 to 12 to 1 ratio. So this counts. Just want to caution you in case you want to do this on your own. You got to always be aware of what that snow ratio may be. So if we look at the snow forecast, and this is the Euro model again, which we just talked about, should be moving things a little bit to the north on this Wednesday afternoon update. So if we go ahead and continue this forward, we'll let it kind of play out so you can see it has. Yesterday, southern Illinois, southern Indiana, northern Kentucky, Cincinnati really kind of had that higher amount swath of snow. Now you can see where that has been moved up in terms of central Illinois, northern Missouri, and then south central Indiana, and then over into southern Ohio. You can see the track of this storm, how it's coming through, right? I mean, if we're looking at places like Evansville, 4 inches of snow, you're looking at Louisville, 7, Cincinnati, around 9. Probably the heaviest snowfall in Indiana is going to be around Bloomington, probably 8, 9 inches of snow. But check out over here, you got far northwestern Missouri that's looking at 12, 13, 14 inches of snow. Now, let's contrast that with the GFS. If we hop over to the GFS and look, we're going to look at the total snowfall here, and we're going to go ahead and play this out. And you'll see it start to move in from the west, northwest, and across the area. So the GFS is now, if you're a snow lover, for instance, this is the model that you probably are drifting back to. And you're starting to see this with the models. This is why I'm not a hype person. I'm not going to sit there and say, oh, this is what we're expecting. No, this is just what the models are putting out. That's a snapshot in time, right? 24 hours from now on Thursday afternoon, these models could be singing something different. Yesterday, the GFS was a little further north. The Euro was a little further south. And then all of a sudden today, the Euro has moved a little bit north. The GFS has moved a little bit south. Is what a meteorologist's job is to see when those models start to line up. And then they will agree on that same track. And then that's when you can start having a little bit of confidence when you publish amounts. So the GFS, for instance, if you look, I mean, you got areas across south central Illinois at 14. You got areas, what is this, 17 inches. Again, around 7, 8 for Cincinnati. But if you look, this swath actually comes in across south central Indiana. You got 13 inches. You got 12 inches. You got 10, 12 inches here. Louisville around 10 inches. Now, is what I want to caution is when you mix in, I've lived, in numerous different areas, and every area is the same with winter precip. If you mix in any sort of sleet or freezing rain, or you have any sort of warm air advection, and warm air advection doesn't just have to happen at the surface. With winter weather, you've really got to be careful with warm air advection that occurs elevated, so above the surface of the earth. So you walk outside, oh, it's 30 degrees outside at my house. Okay, that's great. It may be 35 degrees 3,000 feet up, and that matters when it comes to snow forecasts. So this is what I want to look at. So we're on the GFS now. So if we actually go out and look at the total freezing rain, okay, now I know you guys may freak out, and I get it. I mean, when you're looking at snow versus sleet and freezing rain is definitely going to be you got risk to power and infrastructure and a lot of other risks possible. Plus, it's a lot harder, right, for rural areas to get that snow or to get the sleet and freezing rain off the roads instead of snow once it freezes. So let's put this into motion here. GFS. This is going to be potential amounts of freezing rain. And as you can see, this isn't something that I would trust immediately, but this is something that you need to be prepared for, right? Because you've got areas where you can see up to a half inch that the GFS model is putting out. I mean, even 4/10 of an inch in Louisville, northern Kentucky, even over in western Kentucky. I mean, more than a quarter of an inch. Quarter of an inch freezing rain is devastating in terms of electric and transportation sectors. So again, we need to be watching for this mixture into with warm air and sleet and freezing rain, especially across areas of southern, but more central Kentucky, northern Kentucky, southern Indiana, southern Illinois, southeastern Missouri. I really think Ohio may be safe, kind of because it's kind of coming more from a west-northwest direction. So I am a huge fan of looking at upper air model data, SKUTs. I use a program called BuffKit, and I pulled this BuffKit in. So I'm actually going to move myself out of the way here. So what BuffKit is it's a program that's going to take computer model information and it's going to spit out and show you the vertical profile of the atmosphere. Those of you that have followed me before now, you're going to know that I love talking about this. So just to kind of give you a brief overview of this, so the video doesn't go too long, this dashed angled line here from 0, that's 0 degrees Celsius, so that's freezing. That is the freezing line. As you go up, this would be the surface of the Earth, and then this would be the higher as you go further to the north. This red line, again, is the temperature profile. And again, this is a computer model. This is a forecasted snapshot of what's going to happen. And then the dew point is this green line here. So when you're dealing with winter weather forecasting, you always want to be cautious, again, of any elevated areas of warm air that could somehow affect the type of precipitation. And you want to look for elevated areas of dry air, which on a radar, you can be like, it should be precipitating outside. But in reality, it's evaporating before it gets to the surface. So this picks up at 9 a.m. on Sunday. And if we kind of play this through, I want you to just watch. If you're a snow lover, you want this red line to be to the left of this dashed blue line as I play through time, okay? And you can see it is. But unfortunately, as we get around 9 p.m. Sunday, and again, this is just the GFS, and this is for a location in South Central Indiana that I chose. If you choose Illinois, it would be different, and we can look at that tomorrow. Illinois, Ohio, Central Kentucky, Indianapolis. If we look at these areas, you're going to see different model outputs. But right here is a classic example. This is Sunday at 10 p.m. And again, it's the GFS model. If you walk outside your house, it's going to be below freezing because this is the ground. This is the surface of the earth. However, if you notice, if you go further up, and if we look at how far this is, if we go, it's going to be above freezing around, you've got anywhere around 6,000 feet. So from around 2,500 to around 6,500 feet off the ground is where it's going to be above freezing. And what happens is you get the snow crystals that fall from these clouds, and then they will melt. So you got to think about it falling, right? It's going to fall, and then it's going to melt. The whole question mark is, and this is why I'm not giving any forecast until at least Friday afternoon. And then that's not just because I don't want to be wrong. I may still be wrong giving it on Friday afternoon. It's because you are foolish if you try to give out an actual forecast with a snowstorm 4 days in advance. That's just what it is. But if you imagine this snow crystal falling and it falls through this area of warm air that's elevated, how much does it fall through? Does it completely melt to rain? If this is deep enough being thick enough that it's warm, and it melts, then all of a sudden it runs back into this cold below freezing air right above the surface. Do you know what that's called? Freezing rain. So if it melts, if it goes from snow, it melts to liquid precipitation entirely, and then it refreezes with cold air at the surface, you've got freezing rain. There are situations in which it's 25 degrees outside and it is pouring rain. that is always just, well, for somebody that's into weather, that is awesome. But for, regular people that don't like winter weather, that is terrifying if it's raining at 25 degrees. So right now, I'm looking at a possible situation of freezing rain when it comes in, Sunday afternoon, according to this snapshot with this model. So again, this is why I want to caution you, giving you a little bit more information today on this system. Be sure to stay tuned for more information. We'll try to put out a couple of forecasts tomorrow and then look at some SKU-T upper air data for Illinois, Ohio, and Kentucky, as well as probably around Bloomington, Indiana tomorrow. So again, prepare, have safety plans in action, and stay tuned. Like, follow, share, and subscribe to stay tuned.